When preparing to connect a standby generator to a three-phase high-leg service, it is crucial to consider several special factors beyond standard phase sequencing. A three-phase high-leg service differs from a standard three-phase service by having an additional phase, typically using 4 wires instead of 3. The standby generator you choose must be capable of providing this additional phase. Ensure the generator can handle the specific configuration of your service. Proper connection to the transfer switch is essential for equal load distribution across all phases. Uneven load distribution can lead to inefficiencies and potential damage to equipment. A load balancing panel might be necessary to ensure that the load is evenly distributed across all phases. This panel helps to prevent overloading of any single phase, which is critical for the reliable operation of the generator and the connected equipment. The standby generator may require a neutral connection, even if the three-phase high-leg service does not typically have one. The transfer switch should provide a proper neutral connection for the generator. This neutral connection is crucial for ensuring the generator operates safely and effectively, providing a stable reference point for the electrical system. Grounding is paramount for safety when installing a standby generator. The generator should be grounded according to the manufacturer's instructions and in compliance with local electrical codes. An additional grounding electrode may be required to ensure adequate grounding, protecting against electrical shocks and equipment damage. Voltage compatibility between the generator and the normal utility service is vital. The generator's voltage output should closely match the voltage of the utility service to avoid overvoltage or undervoltage conditions. Overvoltage can damage sensitive electronic equipment, while undervoltage can cause motors to run inefficiently or fail to start. A three-phase high-leg service typically requires a larger generator to handle the increased load. Assess your power requirements carefully and ensure that the generator has sufficient capacity to meet your needs. Consider the total power consumption of all essential appliances and equipment that will be powered by the generator. Hiring a licensed electrician is highly recommended for the installation and connection of a standby generator. A qualified electrician can ensure proper phase sequencing, load balancing, and grounding, guaranteeing a safe and reliable installation. Proper phase sequencing is critical for preventing damage to three-phase equipment. Regular testing of the generator is essential to ensure it is operating correctly and can provide power when needed. Follow the manufacturer's instructions for testing and maintenance to keep the generator in optimal condition. Regular maintenance can help identify and address potential issues before they become major problems. Understanding the specifics of a three-phase high-leg service is crucial for selecting and installing a compatible standby generator. The high-leg configuration means that one phase has a higher voltage to ground compared to the other phases. This can impact the selection of equipment and the wiring configurations required. It is imperative to identify the high leg to ensure correct connections. Always prioritize safety when working with electrical systems. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses, and follow all safety procedures. Turn off the main breaker before working on any electrical connections. It's also essential to understand the National Electrical Code, or NEC, requirements for generator installations. NEC 700 covers emergency systems, NEC 701 addresses legally required standby systems, and NEC 702 pertains to optional standby systems. These articles provide specific guidelines for the installation, wiring, and safety requirements for generators in different applications. For example, NEC 700.12 addresses the wiring of emergency systems and requires that the wiring be designed to minimize the hazards of fire and mechanical failure. NEC 701.11 covers the capacity and rating of legally required standby systems, ensuring they can supply the necessary power during an outage. NEC 702.4 specifies the transfer equipment for optional standby systems, ensuring a reliable and safe transition between the normal power source and the generator. In addition to these NEC articles, it's important to consider other relevant codes and standards. Local built-in codes often have specific requirements for generator installations, including permitting and inspection processes. Compliance with these codes is essential for ensuring the safety and legality of the installation. Furthermore, standards such as those published by the Institute of Electrical and Electronics Engineers, or IEE, provide valuable guidance on the design and operation of electrical systems, including generators. IEE 1547, for example, addresses the interconnection of distributed resources with electric power systems, providing technical guidelines for connecting generators to the grid. When sizing a generator for a three-phase high-leg service, it's important to calculate the total power requirements of the connected loads. This involves determining the volt-ampere or volt-amps requirements of each appliance and piece of equipment, and then summing these values to find the total volt-amps. The generator should be sized to handle this total volt-amps, plus a margin for future expansion. It's also important to consider the starting volt-amps of motors, which can be significantly higher than the running volt-amps. The generator should be able to handle these starting volt-amps without experiencing a significant voltage drop. Load management is another critical aspect of generator operation. By carefully managing the loads connected to the generator, you can reduce the risk of overloading and extend the generator's lifespan. This can involve using load-shedding devices, which automatically disconnect non-essential loads when the generator is approaching its capacity. It can also involve manually switching off certain appliances and equipment to reduce the overall load. Proper ventilation is essential for generator operation. Generators produce heat, and inadequate ventilation can lead to overheating and potential damage. The generator should be installed in a well-ventilated area away from flammable materials. Follow the manufacturer's recommendations for ventilation requirements. Fuel storage is another important consideration for standby generators. Ensure that the fuel is stored safely and in compliance with local regulations. For gasoline-powered generators, use a fuel stabilizer to prevent the fuel from degrading over time. For propane or natural gas generators, ensure that the gas lines are properly installed and leak tested. Regular maintenance is crucial for ensuring the reliable operation of a standby generator. This includes changing the oil, replacing the air filter, and inspecting the spark plugs. Follow the manufacturer's maintenance schedule and keep a record of all maintenance activities. Battery maintenance is also important, as the battery is used to start the generator. Check the battery voltage regularly and replace the battery if it is weak or failing. Transfer switches play a critical role in standby generator systems. These switches automatically disconnect the normal power source and connect the generator when a power outage occurs. There are two main types of transfer switches: automatic and manual. Automatic transfer switches automatically switch between the normal power source and the generator, while manual transfer switches require manual operation. Choose the type of transfer switch that best meets your needs and budget. Surge protection is also an important consideration for standby generator systems. Generators can be susceptible to power surges, which can damage sensitive electronic equipment. Install surge protectors on all circuits powered by the generator to protect against these surges. Regular inspections of the generator and its components are essential for identifying and addressing potential problems. Inspect the generator for any signs of damage, such as cracks, leaks, or corrosion. Check the wiring for loose connections or frayed insulation. Inspect the fuel lines for leaks. If you find any problems, have them repaired by a qualified technician. Noise is another consideration for generator installations. Generators can be noisy, and it's important to minimize the noise to avoid disturbing neighbors. Install the generator in a location that is away from living areas and use noise-dampening materials to reduce the noise level. Carbon monoxide, or CO, is a dangerous gas that can be produced by generators. It is essential to install carbon monoxide detectors in any building that is powered by a generator. Ensure that the generator is properly ventilated to prevent carbon monoxide from building up. Understanding the specific requirements for three-phase high-leg service is crucial for ensuring a safe and reliable generator installation. Work with a qualified electrician to ensure that the generator is properly sized, installed, and maintained. By following these guidelines, you can protect your home or business from power outages and ensure that your generator operates safely and efficiently. When dealing with a three-phase high-leg service, it is very crucial to understand the phase-to-ground voltages. In a typical three-phase high-leg system, also known as a delta system, two phases will have a normal voltage to ground, such as 120 volts, while the third phase, the high leg, will have a higher voltage to ground, often around 208 volts. This higher voltage can create confusion if not properly identified and accounted for during installation. It is important to clearly mark the high leg to prevent accidental connections that could damage equipment. The generator must be configured to properly supply the correct voltages for each phase, and this configuration needs to be verified by a qualified electrician. Another consideration is the type of loads that will be connected to the generator. If there are sensitive electronic devices, it may be necessary to use a generator with a high-quality automatic voltage regulator or other. An AVR helps to maintain a stable voltage output, protecting sensitive equipment from voltage fluctuations that could cause damage. The AVR should be selected based on the types of loads that will be powered by the generator. Generators with digital AVR often provide more precise voltage control than those with traditional AVR. When installing the transfer switch, ensure that it is rated for the appropriate voltage and amperage. The transfer switch should also be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all, to ensure that it meets safety standards. The transfer switch should be installed in a location that is easily accessible for maintenance and testing. Consider the environmental conditions when selecting a location for the generator. If the generator will be exposed to harsh weather conditions such as rain, snow, or extreme temperatures, it may be necessary to install a weather protective enclosure. This enclosure will help to protect the generator from the elements and extend its lifespan. The enclosure should be properly ventilated to prevent overheating. When connecting the generator to the transfer switch, use appropriately sized conductors. The conductor size should be determined based on the amperage rating of the generator and the length of the conductor run. Use copper conductors for optimal conductivity and corrosion resistance. Ensure that all connections are tight and secure to prevent overheating and voltage drops. After the generator is installed, perform a thorough testing and commissioning procedure. This includes verifying the voltage and frequency of the generator, testing the transfer switch to ensure it operates correctly, and checking the operation of all connected loads. Any issues identified during testing should be addressed before putting the generator into service. Keep detailed records of all maintenance activities, including oil changes, filter replacements, and inspections. This will help to track the performance of the generator and identify any potential problems early on. Regular maintenance can help to extend the lifespan of the generator and ensure that it is ready to operate when needed. Consider the use of remote monitoring systems to track the performance of the generator in real time. These systems can provide valuable data on the generator's voltage, current, frequency, and operating temperature. They can also send alerts if the generator experiences any problems. Remote monitoring systems can help to identify and address issues before they become major problems. When selecting a generator, consider the fuel type. Gasoline, propane, and natural gas are all common fuel options. Gasoline generators are generally less expensive but require more frequent refueling. Propane generators offer longer run times but require a propane tank. Natural gas generators are the most convenient but require a natural gas connection. Choose the fuel type that best meets your needs and budget. When operating a generator, be aware of the potential hazards of carbon monoxide poisoning. Never operate a generator indoors or in an enclosed space. Always operate the generator in a well-ventilated area, away from doors and windows. Install carbon monoxide detectors in any building that is powered by a generator. Finally, remember that safety is always the top priority when working with electrical systems. If you are not comfortable performing any of the tasks described above, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is always best to err on the side of caution. Ensure that the electrician is licensed and insured.